What if I gave you a Pythagorean theorem that was actually a real world problem? Now this is a picture of my dog Peanut, and that's Coronado Island. We're going to imagine that there is a mountain on Coronado Island that just so happens that its peak, the two sides of the mountain happen to be perpendicular. All right, here's your real world problem. You know that the length of the base of the mountain is 10 miles. And you know, having climbed one side, that it's 5 miles. How long is the other side? All right. Well, the first thing we'll have to do is, again, start with my Pythagorean theorem. A squared plus b squared equals c squared. Now that you're a pro, I already know that my hypotenuse across from the right angle is 10. And I know that one of my legs is 5 miles, and the other is unknown, so I will call it x. Now I'm going to go ahead and square the values I know. I know 5 squared, I know 10 squared. 5 squared is 25, and 10 squared is 100. Now again, I have this problem where I'm trying to isolate the x squared, and this 25 is in the way. So in order to move that and isolate the x squared, I'm going to subtract 25 from both sides to get x squared equals 75. There's squaring, so I square root. Using my graphing calculator, I plug in the square root of 75, and I get that x is approximately 8.6. That means that this side, a little bit longer hike than the other, is about 8.6 miles. Here's another real-world problem. Imagine that your favorite math teacher is inside of this boat, and she wants to know what's the height of this tree. Now, one thing she does know is that she is 3 meters away from the base of the tree, and if I throw a rope to the tree and I pull tight on the tree, I happen to be able to know that it is actually a 5-meter rope. Oh, that's hard to see. Can you see that? That says 5 meters. Let me outline that in black really fast. That's the sky, so it's harder to see. So that's 5 meters. So now what I'm going to go ahead and do is I'm going to redraw this triangle so I can see it. Now I know that this is 5 meters. I know that one of the legs of my right triangle is 3. And my question is, what is the height of the tree? This is another easy problem to complete as long as you know the Pythagorean theorem. My hypotenuse is 5. So I'm going to substitute in that value. And my two legs are x and 3. I'm going to square the values I know. X squared plus 9 equals 25. I'm going to subtract 9 on both sides to isolate the x squared. And I get x squared equals 16. They're squaring, so I square root, and I get x equals 4 meters. Not a very tall tree. Here's your last example. I'm going to read it to you, and I'd like you to copy it down. Go ahead and pause the video before I start going over the problem so that you have time to copy down the question. Here's what it says. A kite flies with a string 9 meters long. The 1 meter tall child flying the kite holds it with his hands up to the sky. If the child is standing 4 meters away from directly below the kite, how high is the kite? So go ahead and pause the video and please copy that down into your notes. Okay, so let's take this and translate this into some pictures. The first thing I'm going to do is highlight some important stuff. I saw that there was a kite flying in the sky and it was about 9 meters high. Or the string was 9 meters long, I should say. There's a kid, and the kid is 1 meter tall, like a meter stick tall. I also see that the child is 4 meters away from directly below the kite. The first thing, my problem here is I can't see it, so I'm going to need to draw it. So there's this kid. There he is. There's his hair. And there's a kite. Oops, and his hands are up like this. Those are his hands. Okay, He's holding this string to the kite, and this is a 9-meter long kite. Okay. The kid is 1 meter. Well, I'm going to move this over just a little. The kid is 1 meter high. Let's see, what else do I know? The little kid is standing from this location over for directly below 4 meters away from directly below the kite. So the question is, how can I turn this into a right triangle? Where is the right triangle? And what are they asking? What they want to know is, how high up is the kite from the ground? This is the question mark. Now, if only they had asked me they'd given me the string and it was attached to his foot. If it were attached to his foot, I think I could have done it really easily. But they didn't do that. He's holding it like this. So here's my interjection here. The kid is 1 meter high, and if I draw this line in and I make a little rectangle, I know that opposite sides of a rectangle are congruent. All the angles in a rectangle are right, meaning this is a right angle, and this section right here only is 1 meter. So the piece of the whole height that I need is just this piece. I already know, let me grab this orange pen here. I already know this height. I know it's at least 1 meter high, but I don't know how much higher it is from his head there. So what if I just look at this triangle, the triangle right here? Let's redraw it. So just this triangle with the measurement 4 is one of the legs, 9 is the hypotenuse, and that green leg right here that we were missing, that's my x. That's the piece I was missing. Now if I do my math here, we've got a squared plus b squared equals c squared. I'm going to zoom out a little bit and up so we have enough space. I have my hypotenuse, 9 squared, and my 2 legs. I square what I know how to square, so 16 plus x squared equals 81. I'm going to subtract 16 from both sides to isolate my x squared. And my x squared equals how much? 65. They're squaring, so I square root. And using my graphing calculator, I plug in the square root of 65. And I know that 65 is approximately 8.06. That makes sense because the square root of 64 is 8. So I probably could have guessed that it was close to that anyway. Is this the answer to my question? It's not. Because the question was, how high up is this kite? Well, if this section is 8.06 approximately, well, and this piece is 1 meter, then that must mean that my total is my 8.06 plus the 1 meter up of the kid. That means the kite is about 9.06 meters high. Now, as a reminder, I want you to go back to all 5 questions and make sure that all of your answers are represented not only in approximate decimal form, but in simplified radical form. So please make sure you do that for all 5 examples. Good luck.